All right, let's look at number 10. What I'm going to do first, we're trying to find all the zeros. I'm going to go ahead and jump to the rational zeros theorem. So let's list the possible rational zeros, and then we'll figure out which one of those zeros actually works. All right, so remember, to get the possible rational zeros, we need to take the factors of the constant, which is 1, -1, but you can ignore the negative. So factors of 1, well, that's just 1. And then factors of the leading coefficient, which is also 1, again, is just 1. So, wow, this is kind of interesting, right? What are our possible rational zeros? Well, it's combinations of these numbers divided by these numbers, right? But in this case, it's just 1 divided by 1. So it's just plus or minus 1 is the only options that we have here. So we want to go ahead and graph it and see which of these works. So on the calculator, we're going to create this graph. X to the third plus 6x squared plus 4x minus 1. Graph it. Whoop. All right, looks like -1, right? So if I hit trace, type in -1, that does give us a 0 back there. So -1 is going to work out for us. So we do our synthetic division with -1, and then line up our coefficients from the polynomial. 1, 6, 4, -1. Leave some space. Bring down the 1, multiply, you get -1, add, you get 5, multiply, you get -5, add, you get -1, multiply, you get 1, add, and well, they cancel out like they should. Now if we put the variables back in, we're gonna have a quadratic, because it started with to the third power, right? We divided one factor out technically, so we're down to a quadratic, x squared plus 5x minus 1. And we're going to set that equal to 0 so we can continue solving. Okay, so this does not look like it's going to factor nicely, which means we're going to have to use the quadratic formula. So it's going to be x equals, where it's -b, so -5, plus or minus the square root of b squared, so 5 squared, minus 4 times a, which is 1, times c, which is -1, divided by 2 times a, which is 1. Simplify. We get -5 plus or minus the square root of, what does this become? That'd be 25 plus 4, so we get 29 over 2. All right, so the zeros are -1, -5 plus square root 29 over 2, and -5 minus square root 29 over 2. And then you had to factor this problem over the real numbers and then factor it over the complex numbers. So if we factor over the real numbers, just ask yourself, are these all real numbers? Look at the zeros, right? Are they all real numbers? Do you see an I anywhere? You don't see an I anywhere. So yes, they're all real numbers. So we need to build factors for all of these. So we'd have a factor of x minus -1, which is x plus 1. X minus -5 plus square root 29 over 2. And then x minus -5 minus square root 29 over 2. Then look, is there a leading coefficient that we need to put in the front? You look back for that at the leading coefficient from the original problem. It was a 1, so we'd put a 1 there, but we don't need to put that, right? So our, I don't know if this is called f of x or what, but this would be the factored form of that polynomial. All right, and then that was over the real numbers. If you want to factor it over the complex numbers, well, it's going to be the same thing because we didn't have any imaginary values. So I'm just going to draw an arrow back up to this. So the answer should be the same answer for both boxes on the homework. All right, so hopefully that helps.